let's talk about projectile motion. Now we've talked about second order. Now that we have talked about two-dimensional motion, we are ready to talk about projectile motion. Projectile motion is motion that follows a path along two dimensions. The velocities and accelerations in the two directions, usually horizontal and vertical, are independent of each other and must accordingly be analyzed separately. Objects in projectile motion on Earth, such as cannonballs, baseballs, or footballs, experience the force and acceleration of gravity only in the vertical direction along the y-axis. This means that Vy will change at a rate of g, but Vx will remain constant. You know, Vx will remain constant because we neglect air resistance. So usually in projectile motion would neglect air resistance. So in x direction, I emphasize that in x direction is we have constant speed. Nothing changes the speed because we neglected the air resistance. In y direction, either you take it upward or downward, it's a constant acceleration motion. What is the acceleration? Gravitational acceleration, g. The gravitational acceleration, g. Okay. So in projectile motion problems, we solve the problem separately in x direction and y direction. No added formula or nothing else is needed. We just need to know the previous formula, and we need a good command of the previous topics. So a projectile is fired from ground level with an initial velocity of 50 meters per second and an initial angle of elevation of 37 degrees, as shown below. Okay, sine of 37 is given, cosine of 37 is given, but I prefer to say that in a 3-4 triangle, it's better that you learn it that in a 3-4-5 triangle, which is a Pythagorean triple, 3, 4, 5, the angles are 37 and 53. So whenever we have 37 degree, we need to know that it's a 3, 4, 5 Pythagorean triple. It's a 3, 4, 5 Pythagorean triple. So we can easily find the sine of 37 is 3 over 5 or 6/10. Cosine of 37 is 4 adjacent side over hypotenuse, which is 4 over 5 or 8/10. That's it. So I suggest that you learn it by heart, that in a 3, 4, 5 triangle or Pythagorean triple, we have these angles. You will learn it by repetition, of course. Find the total flight time. Okay, so this cannonball will go like this in a I think, no, it's not I think, it's for sure. The path is parabolic, something like this. Total flight time, let's first find let's be concentrated in y direction. So we can say V0y is V0 sine of 37. So this is the V0 vector. Can we decompose it to y and x direction? Yes. So this is Vx, V0x, and this is V0y. So V0y will be V times sine of 37, which will be 30. Now, applying this formula of V is equal to V0 minus GT, this is the same formula as V equals V0 plus AT, but I took the V I took the upward direction as positive, therefore I need to put the acceleration -10. So applying this between the initial firing position and the peak point, this is the peak point, let me take it final position here. At the final position, Vy will be 0, V0 will be 30, so 30 will be 30 minus 10t. It takes 3 seconds for the cannonball to reach the peak point. So another 3 seconds will take it to fall down because it's a parabolic path. And of course, this is the peak point, and the peak point is where we have a line of symmetry. This is a line of symmetry for this parabola. So the total flight time, we've solved the part A of the question as the total flight time will be 2 times 3 or 6 seconds. Okay, we solved it by taking the y direction only, because in y direction we have acceleration. Now, in part B says find the total horizontal distance traveled. The horizontal distance traveled. What is the Vx? So I can say, let me solve it like this. Can I say V0x is equal to Vx because there is nothing to change the Vx, and the velocity in x direction will remain constant. At every second during the flight, Vx will remain Vx, which will be V0 times cosine of 37. So V0 cosine of 37, which will be 40 meter per second. And now we have the total flight time of 6 seconds. Therefore, we can apply this formula and say that, okay, delta x is equal to Vt, because in constant speed motion, distance is velocity times time. Velocity is 40, time is 6, so the distance covered is 240 meter, which we can say the range of this cannon is 240 meter. Let's continue and solve another example. This is another example about projectile motion. The figure below shows 3 paths for a football kicked from ground level. Ignoring the effect of air, rank the path according to the time of flight. Okay, the flight for all of them are the same. The maximum height for all of them are the same. Okay, how can maximum height can be calculated? The maximum height can be calculated like this: Vy squared minus V0y squared will be 2a delta y. Delta y is the same for all of them. A is negative g for all of them. Vy will be 0 at the I'm taking this initial position as I and the maximum height as the final position. In the final position, the vertical component of the velocity is 0 in all 3 cases, no matter which one. Okay, so Vy will be 0 for all of them. A is the same for all of them. Delta y is the same for all of them if written between the initial and the maximum height. So we can understand here that V0y is the same for all of them. V0y is the same for all of them. So I can say v0y of 1, the projectile 1 is equal to v0y of projectile 2, or v0y of particle 3, or projectile 3. All of them are equal to each other. Now, again, let's work in vertical direction. So, do we have this formula? V is equal to v0 minus gt. So, let me take the index of y to insist that we're working in y direction. So, v0y is the same for all of them. And v0y is the same for all of them. Vy is the final velocity at the peak point, so it's 0 for all of them. Again, we're working with this initial position and the final height for the 3 projectiles. Vy will be 0, v0y is the same for all of them, g is the same for all of them, and therefore peak time, the peak time of projectile 1 is equal to peak time of projectile 2 and peak time of projectile 3. All of them will be v0y over g. So bringing this to the other side, we can say t is equal to v0y over g. So v0y was the same, and g is the same, so the time to reach the peak point is the same, and therefore the time of flight for all of them will be the same. So we solve the part A. The time of flight for all of them will be the same. The initial vertical velocity components, we also solved this one. So we said that initial vertical component of all of them must be the same. We solve it here. Part C says initial horizontal velocity component. Now, in horizontal component, we can say delta x is equal to v0x times t. Now, t is the same for all of them. Delta x for projectile 3 is the greatest, and therefore the initial component, the horizontal component of initial velocity for projectile 3 must be greatest. And we know that delta x3 is greater than delta x2 is greater than delta x1. Therefore, because time is the same for all of them, we can say v0x of projectile 3 is greater than v0x of projectile 2, and this is greater than the projectile 1. Now, part D says initial speed, greatest first. So, now we have vertical the same, vertical component the same. This is for projectile 1. This is for projectile 2. And this is for projectile 3. Something like this. As you see, I drew the vertical for all of them the same, but the horizontal one for 3 is the greatest, and then the second one, and then the first one. And therefore, the magnitude of the resultant vector, which is the initial speed v0, is the greatest for 3, and then 2, and then 1. So v0 of projectile 3 is greater than v0 of projectile 2, and then v0 of projectile 1. This is how we should compare these projectiles. I meant to solve some practice questions for projectile motion so that you understand how we work independently in y direction and in x direction to analyze the projectile motion.